We're looking at lesson 60 today. Area between two curves, and then the area between curves using a graphing calculator. In order to find the area between two curves, you are going to evaluate your integral using the graphing calculator. You are going to evaluate the integral from your endpoints. You are going to take the function that is on the top, the highest function, and subtract the one that is below it. You're going to take your highest function and subtract your lowest function. So let's look at an example. Find the area of the region between the graphs on the interval from 0 to 1. So they give us two functions, and we want to find the area that's between the two. What does x squared plus 2 look like if you graph it? And where would your parabola vertex be? Here. And this is a 2. Okay. Where would the line y equals negative x be? Why does it look like that? What is the slope? -1. What is the y-intercept? 0. So it goes to the origin with a slope of -1. So it's falling. Does that make sense? Okay, so our interval is from 0 to 1. Or 0 to 1. So there's 1. And we are looking for the area between the two graphs. So from 0 to 1, we're looking for that area. You see how that works? So to find the area, we're going to set up an integral. What are our endpoints going to be? 0 and 1. What function is on the top? Okay, so we're going to say x squared plus 2 minus what function is on the bottom? So minus negative x, which is what? Plus x. Occasionally, you'll have terms here that can combine, and that's fine to combine them. On this one, we can't combine anything, so we'll just leave it as is. Now, what do you do? Integrate. If you integrate, what would you have? If you put them in descending order? Any questions on that part? Okay. Now what? Nobody? Just because. I'm going to try and report on more. is in the back of my desk. So now what do you do? Okay, you plug in 1. So you'd get 1/3 plus 1/2 plus 2 minus what? If you plug in 0, you get 0. So 1/3 plus 1/2 plus 2. (17/6). Yeah, that's what they have. And it's area, so units squared. Does that make sense? Not too bad, huh? Okay. Now we want to find the area of the region completely bounded by the graphs of 2 minus x squared and x. Usually if they want you to do it by hand and not using the graphing calculator, they're going to be things that you can fairly easily graph. You may not remember when you first see it how to graph it, but it just means you've forgotten it. Do you remember how 2 minus x squared would be graphed? It is a parabola that's opening down, and it's starting at 2. Okay. What about x? Do what? Yes. Diagonal line through the origin. The slope is 1, and it goes through the origin. So what region are we looking for the area of? It's bounded. So where do those like make an area? Like just a small area where it's like in between the two? Here. Do you see how like that area is in between the two graphs? Okay, so we need to find the area from here over to there. What are those numbers? No, it's not infinity. Okay. Yeah, they do keep going. They do go to infinity, but they intersect before infinity. So how do we figure out where they intersect? Set them equal to each other. So 2 minus x squared equals x. So you would have x squared plus x minus 2. Do what? You just got to figure out where they intersect. 1 and negative 2. You set them equal to each other. And usually you'll be able to factor it. So this number is what? A negative 2. And then this one is your 1. So our area is from negative 2 to 1. Which graph is on top? The parabola. Okay, good. So 2 minus x squared minus the one on bottom, which is x. So if you integrate, what would you have? 2x minus 1/3 x minus 1/2 x squared from 1 to negative 2. So you plug in 1 first. and then you subtract, plugging in -2. And so you should end up with 4.5, which they're always going to leave them as fractions, so 9/2. Any questions there? Okay. So let's look at another one. We want to find the area of the region between the graphs of 2 minus x squared and x on the interval 1 to 2. Do we know how to graph those? Did we just graph them? Okay, so I'm going to go back and copy my graph. I'm going to take out my little part there. Where am I looking for the area now? From 1, which is here, to 2, which I say is there. So you're looking for all of that area. Had to extend my parabola. Yeah, you're just shading in between your two graphs. When it says bounded, look for in between the two. So when we do our integral, we're going to say from 1 to 2 because they say use that interval. And our parabola is on top. Is the parabola on top now? What happened? The parabola was on top, but now it's not. So what needs to go first? The line. Do you see how they intersected and the line went above the parabola? Okay, so you're going to start with x and then minus 2, and I'm going to go ahead and distribute my negative and make it a plus x squared. You had minus 2 minus x squared. And if you distribute, you get minus 2 plus x squared. Do y'all understand the difference? Why we had to do the line first on this one? Your line's on top now. Okay, so we integrated this just a minute ago, sort of, but it had different signs. So you can't just copy exactly what your integral was on the other one. Any questions so far? Okay, so if you plug in 2, you would get 2 minus 4 plus 8/3. And then if you plug in 1, you get that. Do you get the same thing? Do you see how that works? Okay. So let's look at another one. Find the area of the region bounded by the graphs of y equals x squared and 2x squared minus 4. If you think about your graph of x squared, it's a parabola. And what about the graph of 2x squared minus 4? Okay, it's further down. Does that make sense? It really doesn't matter. You know they're going to have to intersect at some point because I told you completely bounded by the graphs, and they didn't give you endpoints, so you know that they're going to have to intersect so that you have endpoints. So it's okay if your graph isn't 100% accurate. Now, if they had given you endpoints, they may not ever intersect. They could look like that. So how are we going to figure out where our endpoints are? Okay, so you would say x squared equals 2x squared minus 4. So x equals 2. Why is it plus or minus? When you took the square root. Do we need both of those? Why do we need both? Because you have two endpoints. They're both endpoints. So your area, you're going to use those endpoints, -2 to 2. Yeah, well, your graph, whether they were like bigger or smaller, you could have had it drawn way improportionately, I guess. But which one's on top? The x squared. So you're going to start with x squared minus 2x squared which is x squared minus 2x squared plus 4. If you distribute your negative out. But what is x squared minus 2x squared? Negative x squared. Does that make sense? Okay, so let's say that for some reason I couldn't figure out which one was on top, and I guessed wrong. And so I'm going to pretend this is the integral that you actually want to use, but I'm going to pretend like I did it backwards. So I'm going to end up using this integral, which is similar to the other one. All the signs are switched. And so when I integrate, going to show, I mean, you can still work it this way. I'm going to show you why it'll still work it out. You're going to plug in 2. So that's what I got. Is area supposed to be negative? So if I got a negative, what does that probably mean I did? I did it backwards. So what is my area? 32 over 3. So your actual area would be 32 over 3 units squared. If you slip the graph upside down. Because remember, if you think about it, if it's below your x-axis down here, it's negative. And so if we flipped our graph up, it'd be back up here where it's positive. So if you can't figure out which one is supposed to be on top, just do one on top and one on bottom, and then integrate. And if you end up with a positive, then you guessed right. And if you don't, then just drop off the negative. Does that make sense? So it's okay if you accidentally get them backwards. You don't have to erase all of your work and redo it. It just means that your area needs to drop that negative. Okay, so now we're going to look at doing it on the graphing calculator. Okay, so we're going to go to our graphing calculator, and where are we going to go? Y equals. Why are we going to y equals? We're going to plug in our equations. What are we going to do with our equations? Okay, see where they intersect. Good. I'm going to zoom in a little bit because it's kind of hard to tell exactly what the graphs do. But one of them's a parabola and one of them is a to the 5th, but it only has 2 little humps. Do you see how there are actually 3 intersection points? And there's this area, this big area, and then to the right of it, you see how there's that little bitty sliver of an area? So there are 2 regions that we're going to have to find the area for. Does that make sense? Okay, so we're going to go to calc, and we're going to find intersect. First curve, second curve, guess. Which one's it going to do? Okay, it gave me x equals 1. I only had 2 curves in there, so you just hit enter whenever it gives you first curve, second curve. And so now I want it to give me this one over here. And it gives me negative 0.8670. And then you go back to intersect, first curve, second curve, and I want it to give me the one all the way on the right. And it says it's 1.0 1.5905. Y'all see how to get to those three? Okay, so now what do I do? Okay, how do we find area using the calculator? We did this yesterday. We go to Math 9, and it sets up our little integral for us. So we're going to do from negative 0.8670 up to 1. Now, which curve was on top for this portion of the area? Was it the 1 to the 5th or the 1 squared? The 1 to the 5th is on top. You should get that number. Yeah, that's for the first area. You should get about 6.13, 6.127449339. You got what? Did you change the sign on that 4 at the end? You got to make sure to distribute the negative. And then we're going to do that little sliver. Which one is on top from 1 to whatever that other number was, 1.59? Which graph is on top here? The parabola is on top. You see, this is the parabola, and it's on top right here. And so we're going to go back to Math 9, and we're going to do from 1 to 1.5905, and the parabola is on top. So you start with 2x squared minus 4, and then you subtract x to the 5th, and either put parentheses or distribute your negative for the other two terms. I'm going to distribute to make it minus x to the 5th plus 4x squared minus 1. And I get 0.5631. It should be a lot smaller than the other one, right? Because it didn't look very big. That's actually larger than I thought it would be. So how do we find our total area? And so that you don't accidentally get your decimals mixed up, just go back in your calculator and add them together. And so you should get 6.6905 units squared. Y'all see how to use your calculator? Okay. There were 2 questions to omit on your homework. Number 2 and number 3. Those are again dealing with Maclaurin series. And we're skipping that lesson because it's a Calc 2 topic. So if you take Calc 2 in college, you'll go over them.